This is a attempt to give some motivation and concept to how CPM diagramming can help the project manager. And I use some really poor illustrations here off my computer screen, so if this is helpful, I will work toward making it a much better presentation. But I just want to get your reaction to it to see if it helps. What I have on the screen here is a Gantt chart of a project, which you can see consists of real-world type activities. And I'll make this a little bit bigger so you can see it a little better. And the first step, this is a government project, so the first step is to procure government furnished equipment. And the black line shows that it's scheduled to take about 2.5 months. And right now, the red line, the red vertical line coming down right here, shows that this is the time now. So the red line indicates our current status. So you can see that it's on schedule. Our supplier will deliver it on time in the middle of August. The next activity is to procure some steel for this project, and it's completed. And then what you see, it was scheduled to be completed in the middle of July. It's done. It's on site, ready to go. The next chore we have here is mobilization, and it's completed, as well as the next step, which is excavation and foundation. And then we see the construction is actually beginning here, and we see that steel erection is actually ahead of schedule, and we also see that exterior walls are ahead of schedule. On the other hand, looking down a little bit further, we see that this activity here, mechanical, is actually behind schedule. And the next activity in the list is electrical, which also is ahead of schedule. So that might seem we're in Fat City. If we look at the bottom of this report, let's say we got this from a contractor, you can see the report, the status as of right now is that schedule completion as of this date is 60%, and it's currently 68% complete. So we might say, wow, we're in good shape. But this is what's misleading about a Gantt chart. It doesn't distinguish between the criticality of the activities. So we go to a network diagram, which you see here. Again, this isn't the best illustration in the world, but I'm trying to give you an idea generally how this works. And now you see much more clearly how these activities are interrelated. And you can see, for example, that, and I'll make this a little bit larger, that the mobilization takes 14 days, as you can see there. The excavation takes 7 days, and the foundation takes 14 days. And then at that point, you see an event here. Oops, I lost it. At that point, you see a node right here with my pointing with my arrow here, where that's what we call an event. So this is an AON diagram, and AON diagrams, in my opinion, are better ways to show a project's general overall plan. If you look at AON diagram, as you see in our textbook, it's harder to show it as clearly because the description of the activity must fit in a little box or whatever geometric shape you're using. In our textbook, they use boxes. So you see at this point, this is node 4 right here, and at that point, a lot of things can start, because once we have the steel on site, as you see here, it's on site. Once we have the foundation done, we can begin all these activities following here. We can begin erecting the steel, we can begin the external walls, we can begin the electrical work, and we can begin the mechanical work. Now what we've done differently here in this plan as compared to the Gantt chart is we've shown what activities are critical. What that means is if an activity is delayed, the entire project will be delayed. So you see we have two parallel paths here. We have the beginning of the project. We have along the top there procure steel, and we have these three activities coming along here. 1, 2, 3. The mobilization, excavation, and foundation take 14 plus 14 is 28 plus 7 is 35 days, whereas the steel takes 45 days. So nothing can start over here. None of these activities can start, according to our logic diagram, until the end of the 45th working day. So in other words, this equipment, this work will be sitting still here, for example, waiting until the steel is on site before we can start those other activities. So this becomes the critical activity. So for example, if we had a delay in excavation, let's say a day or two here in this activity, it wouldn't be serious because we have 10 days of what we call slack or float, which we can take advantage of. And we realize that that's not going to bother us because you still have to wait the 45 days for the steel to arrive on the job site. And moving on down further here, we see that the mechanical is critical, and we're going to talk more about in our later discussion here how to find the critical path in a systematic way. And it's really easy to do. It's simple, and it's very useful information. So we want to know at the end of the 60th day, are we in good shape? And so it shows here that procure steel and mechanical are critical activities. So let's go back to the previous diagram. And in that diagram, we saw that the GFE is on schedule, the procure steel is on schedule, the mobilization is on schedule, the erection is on schedule, but we see that the mechanical is behind. Now recall from the CPM diagram that mechanical work is critical. So therefore, any delay in this activity will delay the entire project. So what the contractor has reported to us here is actually incorrect and misleading. They report that their work is 68% complete versus a schedule of 60%. But unfortunately, it's the wrong things for getting this project done on time. And the way we determine when it's going to be done is by adding up the critical path along here. And I believe it's 128 days to complete this entire project. So if mechanical work is behind 4 days, which it appears to be roughly, that means the entire project is delayed 4 days. It's good to know that this ahead of time, because then we can take action, hopefully, to correct the situation. So that's a very quick introduction to the motivation for why we bother with creating a network diagram. I hope this helps. I'll be interested in knowing if this is a helpful description, and if it is, I'll try to make it a better one. Thank you.